I wanted to do an explanation of the problems from the midterm 3 that so we can go over those. The first problem is number one. Steve invests $1,500 in an account that pays 7% interest compounded monthly. How long will it take for this amount to become to grow to $5,000? So we start with our interest rate formula, compound growth or compound interest growth formula. The amount after t years is 1,500 times 1 plus the monthly rate. And so you take the 7% and you divide it by 12 to get the monthly rate, which ends up being this 15 or 1.00583. And you raise it to the 12 times t, because in t years there are 12 times t months in a year, so interest periods in a year. And so that's our formula, and we have to find when the a of t equals 5,000. So divide by 1,500, and this 3.33 is, you want your initial investment to increase by a factor of 3.33. And by multiplying by 1.05833 every month, how many months will that take? Well, one way to do that is to take the logarithm of both sides, and then you use your rule that this exponent comes down in front. And so you have the log of 3.33 equals 12t times the log of 1.05833. And then you can solve for t. I wanted to do that with a little bit more detail in the algebra, but that's a shorthand way to solve this that many textbooks explain, but it loses some of the idea of what's going on when you do that logarithm. So here's how we've explained it in class. So again, we can do that with more steps and some more explanation. The first thing is you change the base. The base was 3.33 and 1.05833, the two ugly bases. Change those to base 10 by using the log base 10. And here, log of 3.333 is defined to be the number that if you raise 10 to that power, you get 3.33. So we just rearranged it so it's log base 10. And the same thing on the other side. And then you can use rules for exponents like this. If you raise a power to a power, you multiply those powers to change this complicated exponent, power to a power, into a product, log of that times 12t. And now we have an exponential equation where on both sides the base is 10, so we're able to then set the exponents equal to each other. And so we set the exponents equal to each other, and that's exactly what we had up above when we did the short version of bringing the exponent down in front. Now we can solve for t just by dividing everything else. Everything's multiplied, so we divide the 12 to the other side, and we divide the log of 1.05833 to the other side. And we solve for t, and it comes out that it's 17.25 years. So it takes a little more than 17 years for your investment to grow by a factor of 3.33 when you're making these monthly interest payments.